Hello class, this is Rishi and I'll be covering the basic topics of statistics today. We'll be touching upon the topics of averages, that is mean, and median. These topics have varied applications in various walks of life, especially given that you guys are going to be pursuing your MBA in a few years time. So this is going to be a very handy tool, and so let us start without any further ado. I'm going to start off with the first topic, that would be average or mean. If you happen to know, then average is defined as the total sum of the number of quantities that we are talking about divided by the number of quantities. For example, if we have a batsman who has scored 10 runs in the first match and 20 runs in the second match, and I want to know what is his average score be, then his average score will be calculated by adding up all the scores that he has made and dividing that number by the total number of innings that he has played. Given that in this example, he has scored 10 and 20, so his total sum is of 30 runs and he has played 2 innings in 2 matches. So his average is going to be 30 upon 2 or 15 matches. So this is about average. Now the second topic, which is of median, is defined as the central value when all the data values are arranged in an increasing or a decreasing order. So you might have a lot of numbers presented to you. In order to calculate the median, you'll have to arrange them in an increasing order, beginning from the smallest number to the largest number, and the number which is exactly in the middle would be your median. So if your number of terms are, say, 5, if you have 5 terms, then the term in the middle would be the third term. So that is going to be your median. So for an odd number of terms, your median is always defined as the central value. But if I talk about an even number of terms, for example, the numbers 1, 2, 3, 4, 5 and 6. In this case, there are 6 numbers. So there is no number which is exactly lying in the middle. So for these kind of problems, we get to the central 2 terms, the middle 2 terms, which will be 3 and 4 because they have 2 terms on their either sides. So the average of 3 and 4 would be the median for the values of from 1 to 6. So the median for an odd number of terms is always the central value, whereas for an even number of terms, it's the average of the 2 central values. Now, we would try and hone our skills in these 2 topics via use of various examples, which would get increasingly difficult, not much different from the way your GMAT exam is conducted. So the first problem would be, you have to find the average and the median of the following numbers. The numbers would be 2, 9, 16, 24 and 32. So if I want to find out the average of these numbers, first I'll have to find out their sum. Their sum is going to be 2 plus 9 plus 16 plus 24 plus 32, which gives me a total of 83. And the number of terms that I have is 5. So my average is going to be the sum divided upon the total number of quantities, or 83 by 5 in this case, which would give me a value of 16.6. Now if I talk about the median, we have 5 terms. So I'll arrange them in an increasing order and the central term would be my median. So if I arrange them in an increasing or a decreasing order, this term in the center is always going to be 16. So 16 is our median in this case. Now if I add another value of 37 into the set of numbers 2, 9, 16, 24 and 32, then the only difference is that the number of terms has now become even. So the average will be still the sum divided by the number of terms. The sum for the previous 5 values was 83. Now I've added an additional value of 37. So my total sum will become 83 plus 37 is equal to 120, and my total number of terms has increased by 1, that has become 6. So my average is going to be 120 upon 6 or 20. Now if I talk about the median would be the average of the central 2 values, since now the number of terms is an even number and not an odd number. So the median is going to be the average of the central 2 values when arranged in an increasing or decreasing order, which is going to be the average of 16 and 24, that will be 40 upon 2 or 20. So this is about the basic definition of average and median. Now I would give you a further illustration to help drive the point home. Now let us assume that there is a student and he has given 4 tests. Now his average in these first 4 tests has been 85 marks. Now how much must he score in his 5th and his last test such that his average is increased by 2 points? So to understand the question fairly, a guy takes 5 tests. In the first 4 tests his average score has been 85. Now I want to find out how much must he score in his 5th test such that his average is increased by 2 points or that his average becomes 87. Now since we know that average is equal to the total sum upon the number of quantities, alternatively I can always say that the sum is always equal to the average into the multiplied by the number of quantities. So in this case, given that the student has scored 85 marks on an average on his first 4 tests, so the sum of his first 4 scores must be the average multiplied by the number of tests that he have given, which is 4 in this case. So his sum of scores in the first 4 tests is going to be 85 multiplied by 4, which is going to be 340. And let us assume that he scored a total of X marks on his 5th test. So his total score for the 5 tests must be 340, which was his total score for the first 4 tests, plus X, which we have assumed is his score on the 5th test. Now this score must also be equal to the final average or the desired average of 87 multiplied by the total number of tests that the student takes, which is 5. So I can say that 340 plus X is equal to 87 into 5, since the sum of the scores in the 5 tests will be equal to the number of tests, that is 5, multiplied by the average score, which is 87. So I can say that 87 times 5 or 435 would be equal to 340 plus X. Therefore X has to be the difference of 435 and 340, which is 95 marks. So this is a basic example of the sort that you will encounter on your GMAT. Now there is an alternative approach of looking at these problems, specifically speaking problems where you are always told what the final average is going to be and you want to find one of the scores in the middle. Now if I say that the average score in 5 tests is 87, it simply means that the sum of the scores in the 5 tests is 435, which is 87 times 5. Now as long as this sum is 435, any distribution is acceptable to me. Now if the final average has to be 87, it is as good as saying that the student has scored 87 marks on each of the 5 tests. Now ideally the situation would have been that he has scored 87 marks on the test 1, test 2, test 3, test 4 and test 5. So in all 5 tests he scores 87 each. But we know that his average score in the first 4 tests is not 87, it's only 85, which is as good as saying that he has scored 85 each on the first 4 tests. Test 1, test 2, test 3, test 4, he has scored 85 each. Now ideally the situation I was hoping for was that he would have scored 87 each on all the 4 tests. Instead he is scoring 85. So basically he is scoring 2 marks less on each of the 4 tests than from our desired score of 87. So basically in these 4 tests put together, he has scored 4 times 2 or 8 marks less than my benchmark of 87. Now since he has scored 8 marks less than the average score of 87, so he must counterbalance it by scoring 8 marks more than the average on the final test. So his score on the final test must be 8 marks more than the average of 87, which will be 87 plus 8 or 95. Now you can see how we have got to the same answer of him scoring 95 marks on the 5th test in order that his average is 87 for the overall 5 tests by using 2 very different approaches. But if you are comfortable with the second approach, you would find that it is always going to be lot easier and a lot more quicker, which is of cardinal importance on an exam like GMAT, where most of the people fumble in the way of not having enough time or not being able to manage their time efficiently. Now There is another problem I would like to share with you, which will probably drive my point home. For example, there is a classroom and you have boys and girls in the classroom, and the total score, the average score of the entire class in a maths test is 90 marks. So all the guys and girls on an average have scored 90 marks. The average score for the class is 90 marks in a maths test. Now, it's also provided that the boys in the class have scored 87 marks on an average, and there are a total of 8 boys. So, up till now, I know the overall average for the entire class, the average score of the boys, and the number of boys. The question also tells me that the average score of the girls is 92 marks. And the question wants me to find out how many girls are there in the class. So the information that has been given to me is the number of boys in the class, the average score of the boys, the number of girls in the class, the overall average score of the class. The things that I do not know are the number of girls, and by extension the total number of students in the class. But I can always say that the total sum of the scores by all students in the class must be equal to the sum of the scores by the boys and the sum of the scores by the girls. Now let me assume that there were X girls in the class. I know there were 8 boys and they have scored 87 marks on an average. Since the sum is always equal to average into number of terms, I can say that totally the boys have scored 87 times 8 or 696 marks put together. Now, similarly, I can say that the total sum of scores by the girls in the class must have been their average into the number of girls, which I have assumed to be X. Or I can say that the total sum of scores by all the girls put together must have been equal to 92X. So the sum of the scores by the boys is 696, the total sum of scores by the girls is equal to 92X. Now, this sum of scores by boys and girls put together totally would also be equal to the overall average into the overall number of students, because sum of total scores will be equal to total average into total number of students. I know the total average is 90, but I don't know the total number of students. But I know that there were 8 students, 8 boys, and I know there were X girls. So my total number of students will be 8 plus X. Hence, my sum of scores of the entire class must be the overall average, that is 90, multiplied by 8 plus X, which would result in 720 plus 90X. Now this is the total sum of all the scores in the class. Now this number, that is 720 plus 90X, must be equal to the total sum of scores made up by the boys plus the total sum of scores made up by the girls. So 720 plus 90X must be equal to 696, which was my sum of scores by the boys, plus 92X, which was the contribution by the girls. Hence, rearranging the equations, I can say that 2x must be equal to 24, or x must be equal to 12. So the answer that I get is there must be 12 girls in the class, so that the average is 90 marks and the average score of 8 boys is 87 and that of the girls is 92. Now, if I use the alternative approach in this question, you would realize how much efficiently I am solving the problem. Now, I know that the boys have scored 87 on an average. So it is as good as saying that all the 8 boys have scored 87 each. Now, also the girls have scored 92 marks on an average, so it's as good as saying that all the girls have scored 92 marks each. And since overall the class has scored 90 marks on an average, it is fair to say that everyone has scored 90 each. All the boys and the girls, everyone has scored 90 each. But actually the situation is slightly different. We know that the boys are not scoring 90 and neither are the girls. The boys are scoring 87 instead of a 90. So every boy is basically scoring 3 marks less than what he should have. So these 8 boys put together have scored 8 times 3 or 24 marks less than our benchmark figure of 90. So since the boys have scored 24 marks less, The onus is now on the girls to score 24 marks above the average of 90. Now we know that the girls have an average score of 92, which is as good as saying that every girl has scored 92. While actually I was looking that everyone has scored 90. So every girl has scored 2 marks more than the average. And I need the girls to counterbalance the 24 marks deficit created by the boys. One girl can counterbalance 2 points on her own. So how many girls will I need to counterbalance 24 points? 24 by 2, which is 12. So you can see that despite using an approach wherein we have literally done almost no calculations that would require you to put a pen to a paper, we could have solved this problem orally. So we can see how average is a very analytical term, because the beauty of it is that all you need to do is to keep the sum constant. So in all such questions where you know what the final average is, you will always use this approach that I have talked to you about. Now I will talk about a few special applications of averages and medians. The foremost amongst them would be an arithmetic sequence or an arithmetic progression, commonly known as an AP. Now what exactly is an arithmetic sequence or an arithmetic progression? An arithmetic progression or an AP is a sequence of numbers where all consecutive terms have the same constant difference. For example, 10, 20, 30, 40, 50. If you notice, the difference between any two consecutive terms, 10 and 20, 20 and 30, 30 and 40, is constant, or a value of 10 in this case. So any sequence of this sort, wherein the first term has a value, say a, and then we have a constant difference x, then the second term would be a plus x, the third term will be a plus 2x, the fourth term will be a plus 3x, so on and so forth. Now there are a few very important clues that averages give us in terms of an AP, and by using these cases you do not need to actually remember a formula of an AP or anything of that sort. The first point worth noting would be that in case of an AP, the average is always equal to the median, or the mean is always equal to the median. You can check for an example. You can take 1, 3, 5, 7 and 9. What is their average going to be? The sum of the numbers upon the total number of quantities. Sum of 1, 3, 5, 7 and 9 is 25. The number of quantities is 5, so the average is going to be 25 upon 5, which is 5. And if you arrange these terms in an increasing order or a decreasing order, you would see that the term which falls bang in the middle is 5, which is our median. So for any AP, the average is always equal to the median. Now this has a very profound application. In case you have a AP given to you and you need to find out its sum, all you can do is you can just calculate the number of terms and you can observe what the median is. Either it will be the central quantity in case of an odd number of terms, or it will be the average of the central two quantities in case of an even number of terms. And then you can just multiply that with the number of quantities to get your sum of an AP. Another way by which you can calculate the average of an AP is by adding any two corresponding terms. Now the average of any AP can be calculated by the average of any AP is the same as the average of the first and the last term, or the average of the second and the second last term, or the average of the third and the third last term, so on and so forth. So if you have terms T1, T2, T3, T4 up till Tn, the average can be T1 plus Tn by 2, or T2 plus Tn minus 1 by 2, or T3 plus Tn minus 3 by 2. So this is how you can calculate an average of a general AP. So the average of a general AP would be T1 plus Tn, or the first term plus last term, divided by 2, or the average of the first and the last term, which is going to be, if you represent it in a general format where A represents the first term and X represents the constant difference, it's going to be A for the first term plus A plus n minus 1 multiplied by X for the last term, which is going to be 2A plus n minus 1 X upon 2 is going to be my average for it is the general format of the average for any arithmetic progression or an arithmetic sequence. 2a plus n minus 1 x divided by 2. Since it is the average, I can calculate the sum by multiplying the average into the number of terms, which I can assume as n. Hence, my sum of an AP would be n upon 2 into 2a plus n minus 1 x, where n stands for the number of terms, a stands for the first term, and x stands for the constant difference. Now, on the basis of these two very simple sounding rules, we can calculate a lot of problems that seem seemingly difficult and complex. For example, if I ask you to find the sum of all natural numbers from 20 to 180, we aren't certainly going to add up all the numbers from 20 to 180. So how are we going to do it? We know that a sequence of natural numbers will always have a constant difference of 1. And since any two consecutive terms have the same constant difference, we can say that this sequence from 20, 21, 22 till 180 is nothing but an AP. And since I know that the average of an AP can be calculated by finding the average of the first and the last term. So my average in this case is going to be the first term, which is 20, plus the last term, which is 180. The average of 20 and 180 is going to be their sum, which is 180 plus 20 is equal to 200 divided by 2, which is 100. And the number of quantities from 180 to 20 is going to be 161. Because both these values are included, the total number of terms is going to be 161. So my sum is going to be the average into the number of terms, or 100 into 161, or 16,100 is going to be the sum of all natural numbers from 20 to 180, where both values are inclusive. Now if I ask you to find out the sum of all multiples of 4 from 4 to 200, how are we going to do it? Since I know that all numbers are multiples of 4, then the difference between any two consecutive terms must also be equal to 4. So basically I need to find out the sum of 4 plus 8 plus 12 plus 16 up till 200. Now this is also an arithmetic progression since all consecutive terms have the same constant difference. The average for this is going to be the first term and the last term divided by 2, or their average. The first term is 4, the last term is 200, hence their average is going to be 204 by 2, or 102. The total number of terms are going to be 50 because I'm starting from the first multiple of 4 up till 200, which is the 50th multiple of 4. So my number of terms is 50 and my average is 102. So my sum is going to be the average multiplied by the number of terms, or 102 into 50 in this case, or a total of 5,100. So we can see how seemingly disconcerting problems can be solved very efficiently using these little concepts. Now, to give you a final example, if I alter this question and tweak this question a little, and if I ask you to find out the sum of all multiples of 4 from 0 to 200 where both values are inclusive, such that all the terms are multiples of 4 but they are not multiples of 6. So basically I need to find out the sum of all such numbers that are multiples of 4 but not of 6 from 0 to 200. Now this is going to be a sequence that looks like 4 plus 8 plus, now 12 will not be included because 12 is divisible by 6, plus 16 plus 20 plus 24 will not be counted, then I'll count 28. So we see that this is not going to be an AP. So how do we solve this? We can bifurcate this question into, I need to find out the sum of all such terms from 0 to 200 that are multiples of 4 but not multiples of 6. So what I can do is, I can find out the sum of all multiples of 4 from 0 to 200 and then subtract from it the sum of all such multiples of 4 that are also multiples of 6 from 0 to 200. So the sum of all such numbers that are multiples of both 4 as well as 6 would be the multiples of their LCM, or their lowest common multiple, which is 12. So basically what we need to do is we need to find out the sum of all multiples of 4 from 0 to 200 and then subtract from it the sum of all multiples of 12 from 0 to 200. The sum of all multiples of 4 from 0 to 200 can be calculated by finding out the average and multiplying that with the number of terms. The average is going to be the first term and the last term divided by 2, or the average of the first and the last term, which are 4 and 200 respectively. So my average is going to be 204 by 2 or 102, total number of terms being 50. So my total sum of all multiples of 4 from 0 to 200 is 102 multiplied by 50 or 5100. Now I need to subtract from it the sum of all multiples of 12 from 0 to 200. Now the first multiple of 12 would be 12 and the last multiple of 12 would be 192. So their average is going to be the first term and the last term divided by 2, or 12 plus 192 by 2. So the average is again 102. And the number of quantities is going to be 16, since 192 is the 16th multiple of 12. So the sum of all multiples of 12 is 102 multiplied by 16, or 1632. So we'll subtract 1632 from 5100 to get to our answer of 3468, which is the sum of all multiples of 4 such that they are not multiples of 6. So this is the sum of all such terms that are multiples of 4 but not of 6 from 0 to 200. So I'll call it a day for our today's session. I'll see you in the next class.